So very good evening to all students. So myself, I'm Dr.R.Sakthivel, Assistant Professor working in a Department of Civil Engineering in Hindustan College of Engineering and Technology. So today I am handling the classes for GATE within a topic of engineering mechanics and construction material management. So these two topics I'm going to cover here. So these two topics comes under the section 2 part as within your structural engineering. So this is the GATE syllabus. For this 2 term, it will having a 6-mark credit. So we can easily score the marks in the topics, in these 2 topics. Okay. So the first term with engineering mechanics, it's having with syllabi with system of forces, free body diagram, and equilibrium equations, and internal forces in structures, frictions and its applications, and center of mass, free vibration of undamped for single degree of freedom system. And second terms with for the construction material and management. So in the subject we are going to see with two subjects. So one part is come under within construction materials and other part with construction management. Okay, so here material and management is very most important in day to day. So because of within a project, whatever the construction project, this is the main 2 role of it acting as vividly. Okay, so within a construction material we are going to see the structural steel compositions, material properties and behavior within a concrete constituents, and mixed design, short-term and long-term properties. And second part within construction management, we are going to see the types of construction projects and project planning and network analysis as per and CPM. Okay, and cost estimation. So these are the topics covered within a GATE syllabus. So this 2 topic within this 2 subject I'm going to take the class for you. So kindly pay attention for these classes. So first we start with the engineering mechanics. Just a minute, I will share the video here. I will share the material. I think it is visible for you. So first part with engineering mechanics. So engineering mechanism is an important analytical tool that allow an engineer to optimize a design or creating. Okay, so engineering means it is a innovation. So we are creating. So we are a creators. So we are going to create someone. Okay. So through the engineering mechanics, so we're having a 2 term. So that is the statics and dynamic loading. So static loading means that is a y-axis loading. Dynamic means that is a x-axis loading. Okay, so within all the direction of x-axis, that all called as a dynamic. Within a y-axis loading. Okay, so that is called point loading, or axial loading, or statical loading. Okay, so whatever, it's all same meaning. So within y-axis, that is called as a static. Okay, so within a scalar and vectors, within a quantities, we can express in a terms of magnitude such as area, length, mass, moment of inertia, energy, power, and volume and work. Okay, so this all come under within a scalar quantities. And similarly for the vector quantities, we can tell as force, displacement, moment, momentum, velocity, and accelerations. Okay, see here, in displacement, velocity, accelerations means, so this all deals within a time period. So without the time period, we cannot able to solve this types of the problems. Okay, so with displacement mean, example, we can take it as a displacement as x. So with differentiation of the respective to the time period, so we can able to find out the velocity, that is dx by dt. Okay, so first time when we differentiate means, that is a x, that is a displacement. When we differentiate of x, that is velocity x dash, and x double dash will be a acceleration. Okay, so with respect to the time, it is called as a vector quantities. Okay, so otherwise we can call as a dynamic. Okay, so in the vector quantities, okay, see here, in the vector quantities, we know that the axis, it will be having some thetas. Okay, so whatever the theta, so it may be the sum of, or multiple of, or subtract, whatever it is. Okay, so if we having two loads or two forces, within the two forces we can able to find out the resultant. Okay, so here x and y, it is there. So within this loading, within the theta of 30°, it is represented. So here we can able to find out the resultant force as 200 with respect to of x and y. Okay, so this is other example for the geometric interpretations of vector, that is sum of c equal to a plus b. Okay, so c, it will be a resultant. Here within a plus b, the resultant we can calculate it as a c. Okay, so it is a other form, that is by moving vector a instead of b, it becomes an evident that one important properties of the vector to addition in that order to material, that is c equal to either, that is c here equal to a plus b or p plus a, whatever it may be. So that will be, that also come as a resultant force. Okay, so here it's all or resultant. Okay, so here are the other vector example, that is for calculating the c, that is b plus a. Okay, so it's a simple term. So mathematically, the simplest way to uh, to calculate the vector within a utilization of Cartesian coordinated systems, so which consists of Cartesian coordinate, means it will be having a three mutual axis. Okay, so three mutual orthogonal axis is called as a Cartesian coordinated systems. Cartesian, you should be keep in memory this. Cartesian coordinate system means it will be having a three mutual orthogonal axis. Okay, that is using designated with x and y, x, y, and z. Okay, so the vector also that will resolve into three components that lie along through three axes. So that is force equal to f of x of I plus f of y by j plus f of z k. Okay, So here all f of x, f of y, and f of z, it is a Cartesian components. So that is taken within a scalar quantities for the force vector of f. Okay, so we can able to compute it by, that is f of x equal to f cos theta x. So if theta x means it will be belonging to the x-axis, x coordinating. Okay, similarly for the f of y, that is equal to f cos theta y. So whatever the force it's coming within your y-axis, that all come under within your f of y. Similarly for f of z, that is equal to f of cos theta z. So here the resemblance of the cos means it will be taken as a horizontal directions. Okay, it's all come under within a horizontal directions. Similarly for when we calculating for the vertical directions, it will be make it as a sine. Okay, so where theta x is an angle and f makes with the respective axis. Okay, so the magnitude f and the force vector f can be expressed in the term of Cartesian components by using the formula. Okay, so here we can able to see one problem on example. See, consider a vector sum, that is c equal to a plus b, shown earlierly. If we know that vector a and b having magnitudes and direction within a figure, so we can resolve them into their Cartesian coordinates. Okay, so that is a equal to, so within here the diagram comes under within 14.5. See here, so a vector that is equal to 20 and b equal to 50. Okay, so that is given in the question. So from the a part, it having a 30-degree, and from b angle it's having a 50-degree. Okay, so just we are substituting here, that is 20, that is for a vector, that is a cos, that is f of a. Okay, so that is 20 cos 30-degree. So 30-degree we having here 30-degree. So 30-degree in I plus 20 cos 60-degree into j. Okay, so see here we having here only the two component x and y. So that's why we are taking as a equation as x and y. Okay, here the z it is 0. So that's why we are cutting as 0. We are not considering the 0 term. Sorry, we are not considering the z term. Okay, so here we having only the two vectors, that is x and y. Got it? So similarly for the calculation of the b, so we having 15 cos theta. So here the theta value will be for b vector, it is a 50-degree. So substitute here and find out the value. Okay, so the resultant sum of c, so that is a question. Okay, so consider the vector sum c equal to a plus b. So we should be find out the resultant sum. C can be computed by summing of the x and y component of a and b. Okay, so that is cx equal to, here we are calculated as 17.32 plus 10.64. Okay, and similarly for cy, that is within the y, that is 10 plus 11.49. Okay, so finally the value will be here for cx, it is a 26.96, and cy it will be a 21.49. Okay, so the vector c can be computed by in a single vector. So this vector we can able to compute it within a single vector. So that is called resultant. Okay, that is c equal to root that is cx square plus cy square the whole square of 1 by 2. Okay, so substitute the Cx and Cy value here and find out the C value. Similarly, for calculating the angle, so that is theta x equal to tan inverse of Cy divided by Cx. Okay, so substitute and find out the theta. Okay, so the vector sum equal to C equal to A plus B we have calculated. Okay, so next terms we are going within a force. So force means you know that some component is coming. So whatever the object, whatever the material or any term, without the force we cannot able to find out the problems. Okay, so as the force of vector quantities, it is necessary to know the both their magnitude and direction. Okay, some force developed under the static condition and some force it come under within a dynamic conditions. Okay, so that is gravitation or magnetic or pressure or electrostatics, whatever it may be. Okay, so other force such as centrifugal and impact force. So impact force is other than this because it will be having a sudden loading. Impact means it is a sudden loading. So whatever it coming within a sudden loading, so that also come under within a impact. Okay, so developed because of a dynamic conditions. It's all come under within a dynamic conditions. Okay, so one important property of the force vector is that to move anywhere along their line of actions. Okay, so we can move along their line within any actions. Okay, so it should be move only the throughout the line. You can see here the figure. Okay, so see here in figure A, F1 is pushing. Is it? F1 is pushing or shifting along the line of actions, so that the pulling will be a happened. Okay, so within the B it will be having a pulling force. Okay, so that resembles with a rigid body remains within equilibrium as force F1 is shifted along the line of action from a point of A to B point. Okay, so now here we're going to consider as loading. So load condition. So force or load, whatever it may be, all are same. So force may be external force that are applied to the structures or internal force that develop inside the structures. Okay, so the external force including the active forces applied on the structures, so as well as the reactional force that developed at the supports. Okay, so in figure 14.7 here you can see that a simply supported beam is loading within a concentrated load, distribution load, and the free body and the support condition. So we having different types of the loading. Okay, either with point load or UDL, that is uniformly distributed, or variable loading. So we can within the load we can see so many types of the loading. Is it? So point load, 1 point load, 2 point load, and UDL, variable load. So likewise we can able to component. Okay, so the force means the load acting. Okay, so this is an example for the concentrate load or point load. Here that is distribution load or UDL. Okay, so next term is with the moment. So moments means we having a result of the force that we acting opposite from a point. Okay, so in the figure itself you can see that the force F tends to make the body rotate with clockwise about the point of 0. Okay, so here the clockwise it may be rotate to the 0. Okay, the magnitude of the moment creates by the situation called as a situation that we can able to calculate it with, that is m equal to f into d, that is force into distance. Okay, so that is m equal to force into distance. Okay, so that's called as a moment. The unit of moment given as Newton meter in SI systems. Okay, so we are following the SI system only. So within a moment, we are taking within Newton per meter. Newton meter. Okay, because the force, the unit is Newton, the distance unit will be a meter. That is unit Newton meter. Okay, so incidentally, a moment that tends to bend a bar in its plane of symmetric as reference to the bending moment. Okay, so one that tends to twist the bar about its long axis is usually termed as torsion. Okay, so when the bar it is coming within on by applying the load, if we applying the point load in a free point, um, applying within a when the load it is applied in a free support, so that is called as a bending. So here in this figure it is a cantilever beam, so here the load it is applied in the free point. Okay, so that is it is called as bending. So this significant is called as bending. And torsion, automatically when it having a twisting, when the bar it is coming within a twisting, so that is called as a torsion. Okay, so next one is equilibrium. So very well you know about the equilibrium. So that is sum of all sum of all h equal to sum of all v equal to sum of all m equal to is 0. So that is called as an equilibrium equation condition. So the basic principle that used in the static to solve for all the forces and the moment acting on a rigid body is based on a Newton's law, Newton's first law, which states that if the sum of all forces acting on your body is 0, the body will either remain at rest or continuous moving with constant velocity. So this condition is referred as an equilibrium. Okay, so see that here itself we having that definition itself we having that equilibrium means it's come under based on the Newton's first law. So this is also one of the important question. Okay, so within what law the equilibrium it will be carried out. So that is Newton's first law. Okay, so within Newton's first law that states that the sum of all forces acting on your body is 0. So that body will either remains at rest or continuous moving with constant velocity. This condition is referred as a equilibrium. Okay, so the external forces. So the external forces it may be differ. Okay, so it's based on the question. So in different mode of the question, it will be having a external forces. Okay, so other important term is equations. Okay, so within that equation we will solve the static problems by representing the force and moment in Cartesian components. So that is sum of all f of x equal to 0, sum of all f y equal to 0, sum of f z equal to 0, and sum of m x equal to 0, sum of my, and sum of m z equal to 0. Okay, so within this equation itself we can classify the force system classification based on the equation of equilibrium. Okay, so see here for equation for the force system with coplanar and coordinate system means the equation should be resembles with f of x equal to 0 and so f of y equal to 0, only the two component. Okay. Similarly for coplanar and non-concurrent forces. Okay, so coplanar and non-concurrent forces means f of sum of all f of x equal to 0, sum of all moment at z equal to 0, and sum of force due to y equal to 0. Okay, so make down this terms and conditions. So this is also one of the important question in the game. So which of the forces based on the which equation of the equilibrium it will be comes under. Okay. Similarly for the non-coplanar and concurrent, so that is sum of f of x equal to 0 and sum of y equal to 0 and sum of z equal to 0. Okay, so that is non-coplanar and concurrent. Similarly for non-coplanar and non-concurrent forces means, so that deals with all the equations, that is sum of all f of x, sum of f of y and sum of m of x, that is moment due to x equal to 0. So that is called as non-concurrent. In other term also we can tell as sum of my equal to 0, sum of fz equal to 0 and sum of mz equal to 0. Okay, so we having, see here, the two forces of x and y with moment of x. Similarly, moment of the y and moment of z with force of z. So these two terms we can able to come under within non-coplanar and non-concurrent forces. Okay. So these are the steps we are following for the finding out the coplanar non-concurrent force systems. Okay. So we can see one. Okay, we can see one problem here. So consider 1000 lb weight suspended from two cables as shown here. So here with 1000 lb within an angle of 60. Okay, so here we want to find out the forces. Okay, so the step one, we should prepare a complete free body diagram of a system as shown in figure. Okay, so this is the actual system. We should draw the free body diagram. Okay, how we can able to draw? So only the three lines. So here we having x, y, and z. Okay, so this is x component and this is y component and this is z component. Okay, similar way we are going to draw here. Okay, so based on the forces, so here the support condition also it is given in the question. So that's why that is T1, T2 and the load. Okay, and step 2, classifying the force system in this problem. Okay, so we should classify the force system in this problem, and the force system in the coplanar are concurrent. Okay, and step number 3, write the applications equation of equilibrium. In this case, only 2 of the 6 equations of equilibrium are applied. That is f of y equal to 0 and f of x equal to 0. Okay, so only the 2 terms. So here the external load it is provided. Okay, and substitute step number 4, substitute the unknown from the free body diagram into the application equation of the equilibrium. Okay, that is f of summation of f of y equal to 0 and summation of f of x equal to 0. Okay, so that is T2. What is f of y? T2, it is on vertical term, so that's why we are taking as a sign. What angle it is given in the question? They have given as a 60 degree. So sine 60 degree. Okay, so make it as sine 60 degree. So this is of sine 60 degree. So why we are taking for the minus? Okay, see here, whenever we are taking a sign conversion, so this is very most important. In vertical term, the arrow is coming within your upward direction means that is positive. Arrow coming within your downward direction means that is negative. Okay, so once again I'm telling that in your vertical component, the arrow is coming within your upward direction, and the arrow is coming within downward direction means negative. Okay, so upward means positive, downward means negative. Similarly for the horizontal line, so horizontal arrows, so towards the right hand side, the arrow is coming towards the right hand side means, so that is we should be taken as a positive. The arrow is going within the left hand side means, so that is a negative. Okay, so this notation is very most important for all the mechanics, all the problems. So that's why we are taking here. See here, the f of y, that is T2 sine 60 degree minus 1000. Why we are taking minus 1000? Because the within a y term, the force is coming towards a downward direction. So that's why we are taking is a minus 1000 equal to 0. Okay. Similarly for f of x, see here, the force due to f of x. So f of x means, so here the T1 it will be a positive, T2 it is a negative. Okay, so that's why T1 minus T2. Okay, T1 minus T2 cos 60 degree. Why cos? Because it is a horizontal, f of x. X means I have told as a horizontal, y means that is a vertical. So that's why sine. Okay, so that is T1 minus T2 cos 60 degree equal to 0. So why here the downward force, it is only, it will be acting within the vertical. There is no any horizontal. Horizontal force is 0. So that's why we are not considering this 1000 lb. Okay. Similarly for solving the equation, so T2 equal to 1000 divided by sine 60 degree, that is equal to 1155 lb. Similarly for finding out the T1, that is equal to T2 cos 60 degree. Okay, substitute and find out the value. So here it is 577 lb. So finally the sixth step, check the solution and interpret the results. The simple way of verifying the solution is to resolve the T2 into the x and y components, and notice that the forces sum of 0 is both direction. Okay, so 0 in both direction. T2 should be greater than W. Okay. So what is a W load? It is 1000. What is a T2 value? It is 1155. So it is safe. Okay. So this all the same problems. I will give this material also, so you can go through the remaining problem. Okay. So go through the remaining problem as, and if you have any queries, you can able to ask with me. Okay. So next one is next topic. So this is very most important in the engineering mechanics, that is mechanics of material. Okay, so each and every material having some mechanism. So whatever, so we can see here, so very well you know about the stress. So stress means that is load by area. Okay, so internal forces that develop into a structural member when it is subjected to a external force generating stresses in the material, although the state of stress is most real structure in complex and beyond the scope of this text. So some simple concepts are useful tool for analyzing many engineering designs. Okay, so stress equal to within a single term we can tell as stress equal to load by area. Okay, and second time with tension. So tension means as stress arise a uniaxial tension. Okay, so example for the tension we can tell as a rope. So within a rope, when we pulling out from one point to other point, so that is called as a tension. Okay, so stress we will denote as a sigma, and so that is equal to, so this is a stress equation, that is stress equal to load by area. Okay, so unit is Newton per mm square. So here we have seen the tension. So load within a load part, it is a tension load, and other as a compression load. So compression means we are giving a load from the top or else within a compressing zone. Okay, so within a material. So that is opposite to the tension. The material which belong the sequence together instead of a pull apart. Okay, so the normal stress of these types of loading is also be calculated by the equation, and the engineer should be aware that any member in compression may suddenly buckle laterally. Okay, suddenly buckle laterally, and especially if it is long and slender, a more complete should refer to be consulted. Okay, so this term only we are seeing in the structural. Okay, so very well you know that short column and long column. Okay, so when we going for the designing, okay, in the DRC, like DRC subject, so the short and long column, which is very most important, so you can identify that slenderness ratio by using the slenderness ratio. Okay, so short column failure by crushing, long column failure by buckling. Okay, so buckling, so whenever we design a structure also we should be taken as a long column, so then only it will be able to come under within a factor of safety. Okay, so totally we are avoiding the short column, so we can do the short column but wherever the necessary term. Okay, so that should be sacrificed by giving some additional techniques in the constructions. Okay, and bending, you all know that bending, so within your load we will be having a component as a bending. Okay, so that is bending describes a more complex states of loading than pure tension or compression. In generally, bodies are weaker and deflect more in bending than in pure tension or compression. Okay, so next term, So although in each state of the bending unit, some general rules are applied. Okay, so what are the main rule is the maximum stress occur where the pure bending moment is maximum. Okay, so knowing the maximum bending moment requires a complete understanding of all the forces acting on a body. Okay, so similarly in state of stresses of the body in bending varies from tension on one side to compression on the other. Okay, so but almost all engineering analysis are based on maximum stresses as given by the equations. Okay, so here within a simple shape we can calculate the moment of inertia. Okay, so for a rectangular moment we having the dimension as BH. So the inertia, the moment of inertia, that is I. Moment of inertia means we will be denoted as a I. So that is I equal to BH cube divided by 12. So this is for rectangular section. And similarly for the solid circular, so that is I equal to pi d power 4 divided by 64. And for hollow circular, it is I equal to pi into d power 4 capital D power 4 minus small d power 4 divided by 64. So this is the moment of inertia value for a simple shapes. Okay. So next one is torsion. So torsion, you know, that is a twisting. Torsion means twisting. Okay. So the slender components in twisting about the long axis. Okay. The circular shaft is in torsion develop a shear stress, that is del, that varies linear from 0 at the center to a maximum to the outer diameter of a shaft. So in the torsion, when the curve arrow is coming towards the downward direction, means that is negative. The curve arrow is going back to the upward direction, means that is positive. Okay, so these are the 6 sign conversion for solving the problems. Okay, so we should keep in the mind for vertical. Once again I'm telling, for vertical the arrow come within a upward direction, that is positive. Arrow within the downward direction, that is negative. Similarly for the horizontal, the arrow is coming towards the right hand side, means that is positive. Left hand side means that is negative. And similarly for the torsion or torque, when you're calculating, the arrow towards the, it's coming toward the upward direction, so that is positive, and arrow is coming toward the downward direction, that is negative. So simply we can tell as clockwise means that is positive, anti-clockwise means negative. Okay. So torsion means torque. So torque means it will be denoted as T, capital T. That is called as a torque. Okay. Twisting. Okay. Tau. So that is tau. So here we are having the simple shear stress are calculated by the equation, that is del maximum equal to, del means deflection. Okay, so that is maximum deflection, that is equal to plus or minus of torque into C divided by J. Okay, C is half the diameter of the shaft. Okay, T equal to applied torque, whatever the we are applying the force. Okay, so whatever the force we are applying, so that all come under within a torque, applied torque. J equal to polar moment of inertia. So polar moment of inertia means we will be calculated. That is, since most of the shaft are circular, so that's why the polar moment of inertia, it will be given within a J. That is J equal to del d power 4 divided by 32. So this is a formula for calculating the polar moment of inertia. Okay, so just we are substituting here, and final the del maximum equal to 16t divided by pi d power q. Okay, so this is for the maximum shear stress. So when computing the factor of safety, so see here the other important term is whenever we going to design or analyzing a structures, so we should be keep on mind within a, it should be compute within a factor of safety. Okay, so when computing the factor of safety, one need to compare the maximum shear stress within a allowable shear strength for the material. Okay, so each and every material it will be having some factor of safety, so that it will be a recommended. Okay, so that value should be a taken. So finding this material property, it's beyond on the scope of this uh, values, and it is published in the total result. So within the mode of ultimate tensile strength. Okay, so within the ultimate tensile strength itself, we can able to find out. Okay, and the next component, that is strain. Okay, so strain, it is a change in length by original length. In simple term, we can tell as a change in length by original length. So that is called as a strain. Okay, so strain, it should be denoted within epsilon. Epsilon. So this is called as epsilon. Epsilon. So that is, if body were perfectly rigid, they would not deflect when loads are applied to them. However, the most engineering material are elastic, which means that they deform linear under load according to the Hooke's law. Okay, so what it mean by Hooke's law? Hooke's law equal to stress is directly proportional to the strain. So that is called as Hooke's law. Okay, stress is directly proportional to the strain. What strain? That is a normal strain. It should be a normal strain. Okay. Okay, see here, the strain in material equal to change in length by original length. Okay. So these are the common material properties. So steel and stainless steel, glass, plastic, and PVC plastics. Okay. See here, the Eng's modulus value. So why this Eng's modulus value is most important means, so whenever you calculating any specifications of the particular material means, so Eng's modulus is very most important to analyze that materials based on. So the material gives more important to the modulations. Okay, so see here, the Eng's modulus, that is modulus of elasticity, or Young's modulus, that gives within a E value. So that is E within a GPa, Pascal. Okay. So within we will be called as Pascal. So for steel, it is roundly with 30, and stainless steel for 27, and aluminium as 10.3, and copper 17.2, and wood 1.6, and glasses 0.372, 0.5, and plastic, that is 0.31, and plastics within here. So in term of Pascal, so this all the term, first term it's come out within Pascal, and Second term is combined with a megapascal. Okay, so within the bracket that is called as a megapascal. Without the bracket that is called that's commanded with a unit of gigapascal. Okay. See here. So next one is the important term is factor of safety. As I already have told that the equation presented with earlier and idealized models that describe material behavior, the material properties of yield strength, and the types of value for the material. However, it is always some uncertain about the actual strength of material. Okay, so similarly there will be always some uncertain about the actual loading, so that a part will encounter. Okay, so the factor of safety we can able to find out within the calculation by f of s equal to material strength divided by applied stress. Okay, material strength divided by applied stress. That is S equal to material strength, S equal to stress. Applied stress means stress we will be denoted as a sigma. Okay, so that is S divided by sigma. And the other term is unit. So for length within SI we are taking as a meter, and with FPS it will be taken as a foot. Similarly for the time we are taking as a both within a seconds. For mass in SI system we are taking as a kilogram, and for other one it is slug. And force we are taking with a Newton, here it is with pound. Okay, and for the gravitational constant G we are taking as 9.8 meter per second square, and here we are taking with 32.17 feet per second square. Okay, so that is two of the units, that is length and time, are independent. So however, in order to force on mass to the mass to be dimensionally homogeneous, so they are related to each other by Newton's second law. So that is Newton's second law, that is force equal to mass into acceleration, ma. Okay, so mass into acceleration. Okay, so for the main term, that is m, that is for moment in SI system we are taking as a Newton meter, and for the stress we are taking as a Newton meter square. On for the strain we are taking as, for the strain it is a dimensionless, because both the unit will be a cancel. For the strain there is no unit, for the stress it is Newton per meter square, and for the moment it is a Newton meter. Similarly for the unit of measures, so that is acceleration means that is meter per second square, that is 0.3048 approximately, and 0.0258 meter per second square. And for the area we will be take it as either with meter square or millimeter square, and for energy it is joule. Okay, so in engineering mechanics now we have seen all the loads. Okay, the first term we have seen the load. Shit. So first part we have seen the loads. And second term, we are going to see in a subject of construction material. So now we're going to see the second subject for the construction material. So here we are going to see about the stone, brick, and concrete blocks. Okay. So in the first chapter, we are going to see here this three material. So very well, you know that the characteristic of the good building. Okay. So good building stone, it should be have with appearance, structure, strength, weight, hardness, toughness, and porosity. Okay. So appearance means the look, it should be a very nice, it should be a fine, and the texture, it should be a compact. Okay. And for the structure, it should be a broken stone should be a bit dull in appearance and should have a uniform texture. So texture also it will have uniform, free from the cavities. And the strength, the stone should be a strong and durable to withstand the stimulating actions of weathers. So that is compression strength of the building stone. It will be range from 60 to 200 Newton per mm square. Okay, and the weight, it is an indication of the porosity and density for stability of structures such as dams, retaining walls, and etc. Okay, and hardness. So this is a property of important for floors, pavement, aprons of bridges. The hardness is determined by a Mohs scale. See here, this is one important question. Okay, Mohs scale. So for finding out the hardness, we will be taken within a Mohs scale. Okay, and for the toughness, the measurement of the impact and the stone should withstand withstand is defined as a toughness. Okay, the measurement of impact that a stone can be withstand. Okay, so whenever we giving impact loading, it should be withstand. So that is called as the toughness. So example, when we applying any vibrations or moving load, it should be a load or anticipated. Okay, so it should be withstand that. So that's called a toughness. And porosity and absorption. So the porosity depends on the mineral constitution, that is cooling time of the structural format, and the porous stone disintegrates as the absorbed rainwater, that is freeze, expands, and causes crackings. Okay, so this is the table of the water absorption stones of volume as per within a percentage. It should not be greater than this. Okay, so example for, so this all the data, it is be taken from the NBC, that is National Building Code. So it all recommended that self. So that data we are sharing. Okay. So for the sandstone, it should not be greater than 10%, and for the limestone, it is limestone also 10%, and shale also 10%. Okay, so now here we are discussing only about the stone. Don't make a confusion with stone and brick. Okay, so first term with we are seeing for the stones. So granite, it should be not greater than 1%, and trap 6%, and gneiss it is 1, and salate and slate 1%, and quartz it is 3%. Okay, and what are the seasoning? The stone should be a well seasoned, so that is within the weathering, and it should be workability, fire resistance. Okay, so seasoning, it should be a well seasoned, and weathering, so the resistance of the stone against the wear and tear. Okay, so this is a very most important. The resistance of the stone with against wear and tear due to any natural agencies. Okay, and workability. The stone should be workable. The stone should be workable so that the cutting, dressing, and breaking out it should be required shapes and size. And fire resistant stone should be a free from calcium carbonate, oxide of iron and mineral, having a different coefficient of thermal expansions. Okay, so that is within a temperature of 575 degrees Celsius. For the limestone, it can be withstand within a light higher temperature, that is 80 degrees Celsius, after which they disintegrates. And specific gravity, for the specific gravity of the stone, it should be in 2.3 to 2.5. Okay. And what are the testing for the stones? So we are doing with the within a laboratory. We are doing with the durability test. So durability test, it's commanded with based on the Indian standard. So recommended by the BIS, that is Bureau of Indian Standard. The durability test are done within a durability or soundness test is performed to find out the capacity of the stone. Okay, and the Smith test. So break off the freshly fired stone chips is to observe about the size of rupee coin and put them into a glass of clean water. Okay, so 1/3 is full. If the water becomes slightly cloud, the stone is good and durable. Okay, if the water becomes dirty, it indicates that the stone cannot do much of airly and mineral matter. Okay, and the brass test and the Bratz test for forced resistance. A few small pieces of freshly quarried stone are immersed in boiled solution of sulfate of soda. Okay, and are weighted. So these are then removed and kept suspended for few days and weighed again. So the loss in weight indicates the profitable effect of the first. And the acid test, so this all combined within durability. Okay, acid test, check the weather resistance. So within 5% of solution of H2SO4 or hydrochloric, that is HCl, or for 3 days, then the chips are taken out dried. The shape and film corner or edges are indicated of some stones. So this test is used to test the cementing material of sandstone. And crystallization test. So according to the IS code 1126, the test is carried out. Okay. And crushing strength. So mostly we are doing this test in the laboratory. So crushing or compressive strength. Okay. So the sample is collected and it will be the surface should be clean and the area it is measured. We are keeping in the UTM. So we are applying a load within the load. So that is for calculating the compressive strength. So load by area. Okay. And the transfer strength test. So that also it's come under within IS 1121 within the part 2. Okay. So here we can able to take the specimen size within a form of 200 into 50 into 50 above. So this test is saturated and dry condition, similar to explain the compressive strength. So this also it's come under within like a compressive strength test. And the tensile test. So this come under within part 3, IS 1121 within part 3. So the tensile test it will be carried out within a cylinder. So normally we are keeping within a horizontal plane and applying the load same within a UTM, and we are finding out the result. Okay, so that is split tensile strength equal to S equal to 2W divided by SDL. Okay, where W equal to applied load, S equal to capital S equal to split tensile strength, and D equal to diameter of the specimen, and L equal to length of the specimen. And find out the value of shear strength. So the rest of the piece, it will be kept in the shear tool. Should be a bar of 50 by 50 mm in section and not less than of 100 mm. Okay, so this test it will teach with IS 1121 with part 4. Okay, so the 100 mm in the length that can, and that for use with a dot punch shear device should be slab with 30 mm in thickness. So 100 mm in wide and not less than with 100 mm in length. Okay, so these are the specifications we should be carried out within a shear strength testing. So for calculating shear strength, S equal to W divided by 2A. W equal to total maximum load and A equal to area of the cross section of the test piece. Next one is absorption test. So this also come under within IS code 1124. So here we have whatever the section, whatever the material we are taken. So just we are taking a weight, dry weight, before immersing in the water. So that is A, and we are taking within a after taking a dry load. Just we are keeping, we are immersing in the water. So after 24 hours, we are taking out the specimen and we are keeping a 10 minutes drying time. So after that, we are going to take the weight. So that is come under within B. Okay, so that is water absorption, that is B minus A divided by A into 100. So these are the common tests we are going to do here. And next terms we are taking for the brick. Next component as a brick. So the standard size of the modular brick is 19 by 9 by 9 centimeter. So the classification of brick, it is classified within the first class brick, second class brick, and third class, fourth class. So the first class brick comes within a water absorption of 12 to 15% dry weight. It should not be more than 20%. And similarly for the second class brick, absorption should be 16 to 20% of its dry weight is unknown. The crushing strength should not be less than 7. Okay, so for the first class brick, the crushing strength will be a 10. The second class brick, the crushing strength will be a 7. It should not be more than 7. Here, it should not be more than 10. Okay. So this is the table according to IS 1077. So the classes as with brick. So here we are taking with the compression strength value. So if the class is 37, the average compression strength will be 35. The average compression strength will be a 35, not less than 35. Similarly, for 30 means it's all be 30, and 25 means that will be a 25. It should not be less than that. Okay, so this is also similar that value. So note that a burnt clay brick having compression strength more than 40%, 40 Newton per mm square are known as heavy duty brick. Okay, heavy duty brick, and they are used for heavy duty structures such as bridges, foundation for industrial buildings, multi-story buildings, etc. The water absorption of this brick is limited with 5%. Okay, so each class of brick is specified, and A and B are tolerance. So here the length of the brick within the dimension, it is be classified with class A and class B. So manufacturing of brick means brick we having within different term nowadays. So within additives in the manufacturing of bricks, and fly ash and sandy loam, within rice ash and basalt stone dust. So within nowadays we having a different terms. So in olden days only they have made within a soil brick. So now we having within different component. Okay. So whatever it is, the preparation of the brick earth is unsoiling, dredging, and weathering, bleeding, and temperature. So within after the weathering, we are going with molding, dyeing, and burning. Okay, so these are the main process it carry out with for the manufacturing of clay bricks. So within the molding, we having different terms. So that is either with hand mold, ground mold, or machine mold. And table mold. So table mold, it is commonly we are using. This is machine mold. So now for the peak, they are using to reduce the manpower. They are using within a machine molding. And drying, we are keeping within a natural process, open to sky, and for a 2 days it will be keeping within a open to sky within a natural ash. So within the temperature exceeds within a normal temperature. And for the burning, it will be having with dehydrated with 400 to 650 degrees Celsius during the clean part. Okay, so after the brick, it will be a spread over in the clean for 2 to 3 days. So after the cleaning, the brick will be taken here. Okay, so the clean burning having with different term, so that is bull touch or Hoffman's clean, and intermediate clean, continuous clean. So different clean are it is available. Okay, so this figure indicates for Hoffman's continuous clean. So here you can see that 1, 2, 3, 4, 5, 6, 7 it's layer. So surrounding the layer, there will be a segregate. If they fill the first 1, 2, 3, 4, 4 up to 5 layer means, so remaining part they will be automatically they will become as within a circular. Okay, so the clean burn, it will be a burning, it will be happening within a continuous term. Simultaneously, they will be check the quality of the brick based on the clean, then they will be removed from one by one stages. Okay, so it is a routine process. So here also you know that it's having a water absorption test. So the brick should not be go with more than 20%. Okay. So the compression strength also it will be carry over with for the brick, it having a compression strength within according to the code of IS 3475 part 1. So that is compression strength equal to maximum load divided by average area of the bed face. Okay. And next important test for the brick is efflorescence test. So this also come under within IS code part 3, that is IS 3495 within the part 3. The end of brick are kept in the 150 mm diameter proclean or glass dish containing with 25 mm depth of water at room temperature. So within room temperature is 20 degrees Celsius to 30 degrees Celsius till the entire water is absorbed or evaporate. So the water is again filled to 25 or 25 mm depth in the dish and allowed to the absorption by the brick or evaporated. The presence of efflorescence is calculated as per below. Okay. So it is light means it is having within a deposit of efflorescence in impression, and with moderate means when the deposit of efflorescence is more than 10% but less than 50% of efflorescence are of brick, and it's heavy when the deposit of effluence is more than 50%. Okay, so more than 50% but the deposited. So all the slit it will be deposited. Okay. So the specification limit of efflorescence is not more than with 10 to 50%. This is very most important term. So the specification limit in efflorescence to be not more than moderate of 10 to 50% up to pluses. Okay, so that is 12.5 and not more than the slide. And fire clay brick or refractory brick. So here the color is whitish yellow or light brown, and it is the water absorption it's taken with 4 to 10%. The minimum compression strength of the brick it should be a 3.5 Newton per mm square. So next material we are going to see with lime mortar. So lime mortar is very most important term in joining the bonding the joinings and bonding the two materials. So it is made within a mixing lime, sand and water. So lime used for mortar may be fat lime, that is quick, or hydrate lime or hydraulic lime. So fat lime has high calcium oxide and hardened with depends on the loss of water, okay, and absorption of carbon dioxide from the atmosphere. So the possible recrystallization is due to causes that the hydraulic lime contains silica, aluminium, and iron oxides in small quantities. So when mixed with water, it forms a putty or mortar having a properties of setting and hardening under water. Okay. So it's a picture of lime, sand, and water. Okay. So this is a mortaring mixing method. So that is Bullock drive mortar. Okay. So by using driving the bull, the mortar is prepared. So this is power drive mortar. So by using the power, the mortar is mixed. Okay. Composite of cement clinker. So within a cement, we having a different components, so that are known as with name of BOGO, who's identified them, Lee Chartier and Throning having a reference. These components are alite, belite, silite, and phyllite, and the following BOQ components are formed during the clinkering process. Okay, so what are that? So one is with tricalcium silicate, it having about 25 to 50 percentage, normally about the 40 percentage of cement. So and with dicalcium sulfate, 25 to 40 percentage. So it is with normally of 32 percentage of the cement. Okay, and for the tricalcium aluminate is about 5 to 11 percentage, normally about 10.5 percentage of the cement. Okay, and tetracalcium aluminoferrite is about 8 to 14 percentage, normally of 9 percentage of cement. And calculation of composites of Portland cement. So within this calculation, we are going to take in the mixing methods. So hydration, the chemical reaction between the cement and water is known as hydration of cement. So reaction takes place between the active component of cement. Okay, so that is chemical term of C4AF and C3A and C3S and C2S on water. So the factor responsibility for the physical properties of concrete are the extent of hydration of cement and the resultant microstructure of the hydrate cement. So this reaction proceeds slowly for 2 to 5 hours, and it is called as indication or dominant period. So as the hydration process, the deposit of hydration product on the original cement drain make the diffusion of water to unhydrate nucleus more and more difficult consequently. So reducing the rate of hydration within their time. So at any stage of hydration, the cement paste consists of gel. So like a fine grain powder, like a fine grain product of hydration, that having a large surface area collectively. So the unreacted cement and the calcium hydroxide, water, and some minor component are used. So they produced as CSH gel represent the calcium silicate hydrate, or known as a tobermorinite gel. Okay, tobermorinite gel. So CSH means, so this is a very main gel. It is providing the hydration process. That is calcium silicate hydroxide. So manufacturing of cement. So first one is the drying process. So in the drying process, the raw materials like quite hard and whatever the hard material, so all it will be made dry. And example with the limestone, clay, or ground in fine powder and separated and are mixed. What is added to make a thin paste. So the cake of this paste, which contain about 14% of moisture and dried on charge in the rotary kiln. Okay. So it is the clinker is obtained as a resulted within about a temperature with 1400 degrees Celsius to 1500 degrees Celsius because of ferric oxide has a lower melting point and the other oxide it's act as flux. Okay, so as aeration of cement clinker, which is commonly practiced to click free lime, also caused an absorption of some moisture and carbon dioxide. So here the gypsum is more important term. It is adding with 2 to 3% of 2 to 3% in the manufacturing of cement. So then only the setting time it will be a increase. Okay. Okay, see here. So by adding the gypsum, it is a coat of cement particle by interfering with the process of hydration of the cement particles. This retards the setting of cements. Okay. So these are the process. It will be taken for the manufacturing of cement. So this is a dry process. And similarly for the wet process. So now next one is the testing of cement. So this is wet process. Testing of cement we having within a laboratory as per the according IS 4031. The finest testing we are conducting by the laboratory and sieve methods. Finest test method we are by sieving the cement. The cement grains are fine than 90 microns. Okay, the sieve analysis method done with a not represent the true means size of the cement grains. Okay. So this is finest test method, and with the sieve method also. So it is also carried out within 90 micron sieve for 15 minutes, and result should be not be exceed limit by specification. So and next test is consistency test. So this is very this test is done within a wicket punch up apparatus within a point of 5 to 7 mm from the bottom of the wicket mold. Okay. So the main importance of this test is the water required for various tests of cement depends on the normal consistency of the cement, which itself depends upon the component composition and fineness of the cement. Okay, so the test procedure it will carry within a simple term, that is 300 gram of cement is mixed with 25% of water. The paste is filled in the mold of the wicket apparatus, and the surface of the filled paste is smoothened and leveled. Okay, so after that a square needle. See here. So this is the apparatus. The square needle. Square needle that is 10 mm. So this is the needle here. Okay, so you can able to visible here. So that is 10 mm by 10 mm is attached in the plunger and lowered generally over the cement paste, so that the surface is released quickly. See here, the mobile, it will be released quickly. Okay, so when the reading is 5 to 7 mm from the bottom of the mold, the amount of water adding is considered to be a correct percentage of water for the normal consistency. Okay. So similarly for the initial and final setting of the time. So this also it will be tested within a wicket apparatus. So we having with the initial setting time as 30 minutes. So within increasing of about 30 minutes or more, it's observed as an initial or final set. So initial setting time is 30 minutes and the final setting time is 120 minutes. Okay. And for soundness test, so by using the soundness, by using the Lee-Chatty apparatus, we are doing this test. So by using the Lee-Chatty method, autoclave method, the test is done here. Okay. So this is the Lee-Chatty method. So within this dia, we are making a cement mortar and pasting within that and inserting in the water. Okay, so the mold is submerged in the water within a temperature of 37 degrees Celsius to 32 degrees Celsius. So after 24 hours, the mold is taken out and the distance separating the indicator point is measured. Okay, so the mold is again submerged in the water and the water should not boil for 3 hours. So mold is removed from the water and it is cooled down. The distance between the indicator point is measured again. The difference between the two measurements represent the unsoundness of cement. So this is the method of doing the Lee-Chatty method. So that is soundness test. And for determining of the strength, we are doing the compression strength. So as preparing a cement mold in the cement mortar and making a shape within a square, we are making in a square shape. So that is the test specimen shot are 70.6 mm cube having with face area of about 500 square mm. For large size specimen, cubes cannot be made since the cement strings and cracks may develop. Okay, so keep in mind, and we should be keep specimen like with small specimens. Okay, so that cube, it is cube we are applying within the load compression. So finding out the maximum load. Okay, similarly for the tensile. So for the tensile, we are applying within a Brick-Newton test method or by the split tensile strength test. So this is the dimension of the standard Brick-Newtons. So here we are taking within the overall as a 76.2 with 44.4. Okay, so here it is kept within a the mold is finished within a smooth and the surface with the blade of a turbo. The surface should be smoothened and they should be kept within a 24 hours in temperature of 27 degrees Celsius to 27 degrees Celsius with plus or minus of 2 degrees Celsius in the atmosphere having with the 90% of humidity. Okay, so the Brick-Newtons are then kept in the clean fresh water and are taken out before the testing. So 6 Brick-Newtons are tested and the average tensile strength is calculated among them. So load is applied steadily and uniformly starting from 0 and increasing at the rate of 0.7 Newton per square mm of the section in 12 seconds. Okay. Ordinary Portland cement having a tensile strength is not less than 2 Newton per mm square after 3 days and not less than with 2.5 Newton per mm square after 7 days. So next one is types of cement. So we have different types of cement, that is rapid hardening Portland cement, high aluminium cement, and super sulfate Portland cement, sulfate resisting Portland cement. So all the all the cement it will be deals within a IS code. Okay, so this IS code is very most important. So see here, for rapid hardening Portland cement, it will become under within IS 8041, and for high aluminium cement, it is 6452. So here the initial setting time is 30 minutes and the final setting time is 10 half maximum. Okay, so similarly here for the high aluminum cement, it will be having with strength within maximum width. So that is initial time is initial setting time is 30 minutes and the final is 2 hours. Okay. So the uses of this high aluminium cement is it is resisting to action of a fire, seawater, acidic water, and sulfate, and used for refractory concrete and industries, and it is used widely for precasting. It should not be it should not be used in places where temperature exceeding 18 degrees Celsius. Okay, and super sulfate Portland cement. So that's code come under within IS 6909, the manufacturing of integrating air intimately blending a mixture of the granular blast furnace. Should not be less than 70%. So calcium sulfate and small quantity of the 33 grade Portland cement. So in the cement, tricalcium aluminate, which is suspectably to sulfate, is limited to less than 3.5%. So it is used only in a place in the temperature of 40 degrees Celsius. So the compression strength of the test is for 1 hour it should be reached 15 Newton per mm. For 2 it should be 22 Newton per mm, and for 4 it should be 30 Newton per mm. Okay. It should have the fineness of 400 meters square by kilogram. So it can be expansion of cement is limited up to 5 mm. So the initial setting of the cement should not be less than 30 minutes, and the final setting it should not be more than 600 minutes. Similarly, for the sulfate resisting Portland cement, it's deal with IS 12330. The compressive strength is for 1 hour 10 Newton per mm square, for 2 hours 16 Newton per mm, and for 4 it should be 33 Newton per mm square. So here also the final initial is 30 mm. Should not be less than 30 mm, and the final setting time should be not less than 600. Sorry, here it is minute. Okay, so it should not be less than 30 minutes, and the final setting it will be 600 minutes. In Portland slag cement, it's come within IS 455. So it's come within a glass containing with silica and aluminum, silicate of lime and other bases. The next one is low heat Portland cement, comes within IS 12600. So that is here also the the initial setting time is 60 minutes and the final setting time is 600 minutes. So on the compression strength, 1 hour it is 10 and 2 hour it is 16 Newton per mm square, and for 4 hour is 35 Newton per mm square. Similarly for the Portland Pozzolana cement, so now this cement we are using, that is PPC. Okay, normally we have in the short form we have convey as PPC. Okay, Pozzolana cement. Sorry, Portland Pozzolana cement. Okay, so that is PPC, Portland Pozzolana cement. So usually the fly ash of 10 to 25% of the mass of PPC. So here for 1 hour it is 16 Newton per mm square, and 2 it is 22 Newton per mm square, and for 4 33 Newton per mm square. So the initial setting time is 30 minutes and the final is 600 minutes maximum. Quick setting Portland cement. So initial setting time is 5 minutes and the final setting time is 30 minutes. And machinery cement. So here the setting time will be max. Initially is 90 minutes and the maximum is at 24 hours 1 day. And white and color Portland cement, it's come with an IS 8042. So see here, I will convey all the notes to you. Each and every cement having IS code. Okay, so the question may be rise up within the what type of the cement which deals with the code, which code. So that also it will be happen. Okay, so that's why I'm taking this. So kindly note down when and there, then and that itself. So whichever the cement resembles within a IS code. Okay. So up to this, from to cement, we are stopping in construction material. In next class, we can see the continuum of the engineering mechanics and the construction material. Okay. So up to this, you having any doubt or you have any queries, you can freely ask any questions to us. So we are ready to clarify your doubts. Then and that itself. So thank you for pay attention here. So do you have any doubts? You can freely ask here. So you can contact me with my mail ID or you can contact with my mobile number. So thank you for all. We can see by next class for remaining classes. Thank you.